Thanks for being here. We are so excited to have these esteemed panelists here. I'll have them introduce themselves in a minute. My name is Allison Schwartz. I'm the Senior Vice President for Global Government Relations and Public Affairs at D-Wave. And one of the things that I am most excited about is making quantum computing technology actually tangible for the non-technical audience. I'm a poli-sci major myself, so anytime we can delve into emerging technologies, national priorities, and applications, I'm all for it. So thank you all for being here. Thank you to my panelists, and thank you to Yale Ventures for hosting this amazing symposium. Why don't we start with each of the panelists kind of introducing themselves and give a kind of like a quick background about what you do for the company and what was your quantum journey. So with that, Mark, over to you.
Is this on? Can you hear me? Good. So hi everyone. I'm Mark Jackson. I'm the Senior Quantum Evangelist at Quantinuum. So I do a lot of the public-facing activities. So this could be speaking at conferences or doing investor relations or meeting with academic partners to talk about collaboration or recruiting. And I have a physics background.
Good afternoon, everybody. Thanks for having me here. It's my first Yale Innovation Summit. My name is Jason Silbergleit. I head the Americas for Classic Technologies. I have a pretty interesting quantum journey. I'm a ceramic engineer by background, but spent almost 30 years at IBM, most recently leading the global quantum sales team, our generative AI in research. But at the time, I recently joined Classic about 2 months ago, at the point where I recognized that quantum is not an if, it's a when. And I think you'll hear from my esteemed colleagues here that when is compressing. And the ability to make this technology tangible for all of you is incredibly important. And Classic, which I'll go into more detail later, is really about the software stack that makes an industry usable by end users.
All right. Hi, everyone. This on, right? Yeah. My name is Andrei Petrenko. I'm VP of Gate Product Management at D-Wave. For those of you who don't know, D-Wave is a full-stack quantum computing company, and it is the only dual-platform quantum computing company in the industry where we provide both annealing quantum solutions and are developing gate products in parallel as well. On a personal note, I'm really glad to be back here at Yale. This is where my roots are in New Haven. I've spent 10 years of my life here. I got my PhD just around the corner in Rob Shulkoff's lab. And after that, I joined a quantum computing hardware startup that he spun out. And that startup, Quantum Circuits, was acquired by D-Wave just this past January. So it all feels like everything's come full circle. I'm back here now, and I'm really glad to be participating in the panel.
Thank you so much. So, we've heard the names of the companies, Quantinuum, Classic, D-Wave. My guess is most people actually don't know what they are. So we have hardware quantum systems, we have software quantum companies. So I'm going to kind of go down the line. And I guess, Jason, I'll start with you in the middle. Talk a little bit about kind of, what is the difference of software versus hardware? What does Classic roles play in the quantum ecosystem?
Yeah, so, you're hearing a lot about hardware, and we hear a lot about hardware, but what's really exciting about this time is, we are building a new industry. And make no mistake, all of you are building a new industry. And industries will have a diversity of players. You'll see diversities of hardware modalities. You'll see superconducting systems. You'll see ion trap systems. You'll see neutral atom systems. You'll see photonic systems. But at the end of the day, what really scales for use is the ability for the end user to be able to utilize the best of all of those systems. And for that, you really need an orchestration and a software layer that enables you to do your work and then port it as needed for the applications that are needed, especially as you go into a hybrid classical quantum environment. So our software, which is very exciting to me and I think will be exciting to you, actually is an abstraction layer. So if you think about quantum today, a lot of folks still talk about physicists and deep STEM expertise to be able to go in and create quantum circuits. What our software does is it abstracts out that complexity and enables the end user to focus on the use cases, the algorithms. And then once you have the algorithm, you can simulate it on GPUs, you can simulate on any gate, and then run it on any gate-based quantum computer. So when you start your journey, you're not stopping if one modality, becomes more prevalent than another. You actually can port your algorithm as the hardware evolves and as the quantum journey evolves. So we're very excited to ensure that our clients are able to start that journey with confidence, independent of whether you not know exactly when quantum is going to be hit in your use case or exactly who the winner is going to be, because you should start now. And I think that's a theme that you'll hear throughout the day is quantum is coming, and if you don't start now, it may be a problem when it's here.
Mark, let's go over to you. Obviously, as Jason set up, there's ion traps, so superconducting. Why don't you talk about a little about the Quantinuum roadmap? And obviously, as somebody who is an evangelist and a PhD, you have a really unique perspective on this.
Thank you. Yes. So yes, as I mentioned, my job title is quantum evangelist. It's a bit unusual. So I learned in Greek, evangelist means bringer of the good news. And so a lot of what I do is kind of create education and excitement about what's happening in quantum computing. I will say the only really negative reaction I've had to my title, I was on a second date, and she told me that our child, second date, would be running for president, and how could they possibly do that with a father who had the job title quantum evangelist? So that will need to change. There was no third date. So it's a really exciting time, and like a lot of new technologies, there's a lot of misunderstanding about what quantum computing is, and so that's a lot of what my job is. So at Quantinuum, we do everything. We were the merger between Honeywell Quantum Solutions, which developed quantum hardware, and Cambridge Quantum Computing, which did quantum software. And so we do everything. We have almost 700 people. So we use ion trap technology, and we have the world's most powerful quantum computer. Right now, we have 98 physical qubits, and we have 48 logical qubits. And so it's amazing how quickly things are progressing. And then on the software side, we do a lot of collaborations, and we work with companies to develop use cases that can benefit from quantum.
Fantastic. Andre, we've heard about ion traps. Jason mentioned a whole host of other hardware. Why don't you talk a little bit about, from your perspective, about the work happening here in New Haven as well as across D-Wave?
Yeah, sure. So as I mentioned, as I alluded to in my opening, D-Wave is the only vendor in the space that's a dual platform quantum computing company. And what that means is we offer both annealing quantum solutions, systems, and services, and are developing gate model products. So on the annealing side, those kinds of products are really tailored towards, and they're really good at solving optimization problems, workforce, scheduling, logistics, and those problems are commercial ready today. Those systems, the annealers, are commercial ready today. We have a number of customers with whom we're working with. We're shipping systems to them. We have cloud services that are being accessed by them. They include customers like BASF, Johnson & Johnson, NTT Docomo. And, it's a real kind of, it exemplifies the maturity of quantum annealers that they're being leveraged in this way already. Now, on the gate model side, these systems, gate model quantum computers, they're a little bit different. They're not really kind of geared toward optimization as well. They're more, they're better suited for chemical simulations, simulating materials design or improving the efficiency of batteries, things like that. And they're more in their R&D, in the R&D phase today. There aren't as many qubits, and the biggest kind of goal that we have with gate model systems is getting to the point of error correction and fault tolerance when commercially viable use cases are going to become a reality. And so we have a roadmap that we have in place at D-Wave that accelerates our kind of path to getting to fault tolerance with unique with a unique technology that we call AeroWare dual rail qubits. And that's where my role comes in leading that product roadmap. So we're very excited about that. And one of the kind of best aspects of having this dual-pronged roadmap that covers the annealing and the gate model is that now you have kind of a strategy that covers all use cases that customers may want to cover across the quantum industry. And that really is going to deliver, is already delivering, and will continue to deliver a lot of value going forward.
Let's talk about those customers for a minute, because I think that's where kind of the rubber hits the road, because we are all excited about what's inside the box. We're really excited about how it works. But in reality, it's about what it can do and what are the areas. So if you look at Connecticut, Connecticut's major industries are advanced manufacturing, aerospace, you have financial services, life sciences, energy. You know, where do you see your systems and your technology kind of impacting these industries? And if we had a room full of these industries, CEOs and CIOs and CTOs, how would you want them to engage with the company? So I'll start with you, Mark.
Sure. So one of the biggest misunderstandings is that quantum is just a faster computer, and it's not. Quantum is only good for very specific use cases. And so the first conversation that we should have with a potential customer is, what is your bottleneck? What would you want to use a quantum computer for? And so then we have to identify like what are the exact challenges. And so then if we can come to an understanding of these are your challenges, this is what a quantum computer could do, then that's the beginning of the collaboration. And so I think that has to happen before anything else. As you said, in Connecticut, there's a lot of focus on financial services. There's a lot of biotech, as you can see here at the summit. And fortunately, those are two of the prime cases, because in chemistry, normal classical computers have a lot of difficulty solving the equations that we would need in chemistry, whereas quantum computers are very efficient at it. And then in financial services, we do a lot of modeling using Monte Carlo simulations. And it turns out there's a quantum Monte Carlo algorithm. And so that can lead to more accurate results faster. And so that's the good news, is that it's very relevant to industries here in Connecticut.
Fantastic. Jason, what are your thoughts?
Well, I think, again, quantum computing opens up new spaces for exploration, new spaces for value creation, new use cases. I do believe that Connecticut is well positioned because it's got a very, very broad set of industries from, as you said, fintech, insurtech, pharma, life sciences, A&D, whether that's new materials, new chemistries, new therapeutics. On our software, what we take pride in is actually having the largest library of code today, quantum code. So clients can go in, and we have a large set of enterprise clients across all industries, including the ones here in Connecticut, that can actually use that code and create their algorithms today. And again, you can step along that journey. So you can start by looking at how does that simulate on GPUs? How does that work on various gate-based systems? You can use those now and create those circuits now. So like I said, I think all of these industries are going to benefit. But I do agree with Mark that you have to actually identify what use cases make sense for quantum. Quantum does not replace classical. Quantum augments classical. And the real value is going to be when these come together as really the future of computing in terms of classical plus AI plus quantum.
Great. Andre?
Yeah, no, it's a good question. And look, I've been, in this area for many years now, and I've seen how it's evolved into this incredible, quantum innovation anchor in the region. And there are so many incredible industries, not just in New Haven, but in Connecticut at large. And quantum can play a really key role in making Connecticut really like a global leader in high performance computing. So, there are a number of opportunities in how we can get involved. It can be in direct engagements with these industries, identifying the different use cases. One of the big advantages in having a dual platform strategy is that some of the industries could really benefit from having from using annealing QPUs for optimization purposes, and those are ready today. Whereas others, in particular, academic institutions like Yale and UConn, we could easily work with them on gate model R&D efforts. And in fact, we have seed programs with Quantum CT already underway with that. So I think it's really getting involved and plugged into that ecosystem, that really vibrant ecosystem that exists in Connecticut right now, and just continuing that activity. I think it's going to yield a lot of really tremendous outputs longer term.
I want to pull on a thread, Jason, that you mentioned about quantum not, replacing classical, but can augment it. There's a lot of conversations about AI and ML and quantum and this. Talk a little bit about how you see the synergies. What are the roles? Where is, there's a lot of misconceptions of what quantum will do and what it won't do. But I would love kind of from the software stack perspective, how do you see that playing?
Yeah, so I think as we've said, I don't think people should look at this as, okay, I've got a great LLM, I'm now going to do quantum, right? I think you have to look at this at what spaces it opens up. It opens up, as you said, areas where it simulates nature, quantum mechanics, right? So that's why things like molecular discoveries, chemistry, materials discovery are we're so excited about, because these new materials, as we talk about industries, clean tech, you talk about pharma, what if you can actually get to a therapeutic much faster than having to go through the level of testing that it takes now to get a drug to market? What can you do if you can simulate things for rare disease therapeutics that are not available today? What can you do if you can find more feature spaces? You can explore more spaces around optimization, right? So there's a whole bunch of things that it opens up. Now, what does AI do? AI, artificial intelligence, right? It looks at all the data and then is able to make some intelligence out of the data. I think quantum is a new space of compute. So it's just it's another modality of compute. It doesn't replace it. It augments. So there's some areas that you're going to use AI. And by the way, many of us are using AI today with quantum. For example, in our software, right, we're trying to make it as much easier for people to build their algorithms through using natural language interfaces to create their quantum circuits as well. So there'll be AI plus quantum, and then there'll be problems that require some AI capability plus quantum. And I know there's work being done on how do you actually improve feature selection, et cetera, in AI through quantum and looking at new features, et cetera. So there's and by the way, I think this is also, and I'll ask my colleagues the same thing, I also think this is a major area of exploration. And I again, look at the academic universities. The first thing was, what can you do with quantum? Then there's AI. I think that a real opportunity for academic exploration is going to be, show us where AI and quantum really work together to do something that is, extraordinary.
That's great. Do either of you want to comment? Mark, why don't we start with you?
No, I think that actually is.
You got it. All right, Andre.
Yeah, sure. So the way I look at kind of the landscape here is, I break it down into two categories. There's AI for quantum and quantum for AI. And in the AI, so in the first category, in the AI for quantum, we're seeing it in use a lot today. There's more research coming out where the AI is used to enhance how quantum systems are being scaled, how calibration techniques are being improved, how error correction is being implemented to essentially improve uptimes, or so systems can be accessed for greater periods of time by customers. All of this is very valuable stuff. There is also a tremendous amount of value in the future for a quantum for AI, and this is we're gonna see this on the gate model side, where we could be generating high quality data, error corrected data that can be ingested by AI models to predict to help predict, again, generative models for molecular design or materials design. But also we're seeing this on the annealing side. And we've made a lot of progress at D-Wave on the AI commercial end as well, with our work with Shionogi, the pharmaceutical division of Japan Tobacco, where we've identified new molecules for new drug targets for the LLM models that we were building with them. And those were some of the first examples of really quantum improving AI workflows with LLM. So there's some really exciting progress being made in both of these categories, AI for quantum and quantum for AI, and I think we're just going to continue seeing that trend continue going forward.
Can I just add one thing? So obviously you know who NVIDIA is. That needs no introduction. We've been working with NVIDIA for several years already. Last year was a big year for NVIDIA and quantum because the year started with NVIDIA announcing that they wanted to build a quantum research center in Boston, and the first partners were Harvard, MIT, and us. And then the year ended with them saying they just wanted to start building quantum computers right next to their data centers. And so we're already starting to see this integration directly between quantum and AI and in GPUs and such. I will also say in our compiler, when we do quantum error correction, it turns out that the error correction process is very efficiently done with GPUs. And so again, we're already starting to see these come together.
Great, thank you so much. I mean, I would be remiss if I didn't start talking about government funding. I mean, this is a panel about emerging technologies and national priorities. We had the U.S. government make a very large investment in several different quantum companies through CHIPS funding. You had the Department of War's Microelectronic Commons getting additional funding. You had the governor of Connecticut, who's taken a big step into quantum funding and advancements. There's been federal funding for quantum CT. Mark, let me start with you. Kind of what is the most important thing you see that the government could do to accelerate quantum readiness, especially for national priority applications?
Yeah, so last week was a great start. I'm sure many of you saw the headlines that they provided $2 billion in funding for quantum technologies. There's different groups and different sectors that this is going into, but this was fantastic news, and especially because up until now, historically, most of the government funding went to national labs, which is good, but there's a lot of private companies now which would benefit from it. And so this was a really good step in that direction, that the money's going towards private companies. The other role that governments can really play is funding basic science, because of course, companies won't step in until they see some window of opportunity towards profit. And so that's where the government could really help us with things.
Great. I'm going to go to the hardware and then we'll end with software for this question. Andre, what are your thoughts about what can government, either state, federal, or local, do to help with readiness?
Yeah, absolutely. So, in my view, the government is really good at kind of big ticket investments, kind of to Mark's point. Along the lines of manufacturing, supply chain, fostering really positive relationships between industry and academia. And I think the CHIPS Act announcement is a really good example of that in action, and it's really a tremendous sort of endorsement of the quantum computing in the country, and sends a really powerful message. So, D-Wave signed an LOI for $100 million with the administration, the U.S. Department of Commerce, and that funding is going to be used to accelerate both our annealing and our gate model programs across our key R&D centers, from Burnaby to New Haven, and our upcoming R&D center in Boca Raton. And, again, key areas of innovation there are going to be along those similar lines for areas like workforce development and supply chain manufacturability of these devices, all kind of areas that play to the strengths of what what I think the government is very good at investing in. So I think this is, again, a very powerful endorsement for D-Wave strategy and sends a powerful message globally for how the U.S. is pursuing quantum computing aggressively.
So most of the funding has been in the hardware. I'd love to get your side of it, Jason, for what should the government, either federal, state, or local, be doing to help with the software readiness?
Yeah, so first, I do want to agree with my colleagues. I think it's really important that the government plays a role to help accelerate industries, especially in capital-intensive areas. I think, make no mistake, this is not just about companies here, it's about geopolitical positioning, right? And this is a race, right? And having a very vibrant and diverse set of U.S.-based companies or allied companies that have this technology is incredibly important. I also think, the announcements that the government made across the various quantum companies, but also creating the quantum foundry, I think offers a level of equality to both startups and established companies to allow them to compete and create that diversity of supply chain. And, on the software side, people said, well, what do you think of that? I have two responses to that. On the hardware side, I do believe that we are creating, I go back to this. This is not a one company race. Some people will say it's a one company. This is an industry. We're creating an industry, right? An industry will have multiple winners. Okay, this is not a one winner take all industry. And when you have multiple winners, you need a cohesive layer that allows end users to access that set of winners. And that's where, I am personally very passionate about where Classic sits in the stack, but collaborating with colleagues here on the panel and elsewhere to ensure that their systems are accessible to anybody, right? What I'd like to see, though, the government, if you look at that $2 billion investment, and I understand why it's the way it was hardware-based, right? Let's make no mistake, every company that received funding was to accelerate hardware. Now, the best way to accelerate adoption is to make sure the end users can take advantage of that hardware. So I think it's time that we get a little bit more funding. And actually, the government's doing the right thing by starting with making sure the technology, the software is only going to be as good as the hardware is getting to an ROI advantage. We all recognize that. But software has to be in place because I always use this analogy, and I'm gonna age myself, so some of you, I remember in college, my roommate had this computer that I didn't even know the name of it. It was like some wacky computer that did something that, and then I had a different computer, and we all used different, and computers were like, it was, you used it. And then came like Microsoft Windows 3.0 or 3.1, and all of a sudden it didn't matter, right? You used that operating system. It didn't matter if you had an IBM or a Dell or a Gateway 2000. I'm really dating myself. Okay, whatever it was, it didn't matter because at the end of the day, all that people cared about were the outcomes. Can I do a spreadsheet? Can I do a Word document, et cetera? So that operating system that sits on top of it is really where you're starting to get that hockey stick of adoption. And we really want to make sure that again, in the U.S. and our allies, that we're creating that software stack to really control the outcomes of the industries, the adoption of the industries, working very closely with the really exciting advancements that Quantinuum is making, that D-Wave is making, that others are making in the hardware side. So it's a very exciting space. Stay tuned. We're looking forward to some funding coming the software way as well.
That's awesome. And I know that there are pieces of legislation moving through Congress, the Quantum Sandbox bill that's focused on application development in 24 months or less. I know that's stuck in the quantum realm of the National Quantum Initiative reauthorization and other things like that. But organizations like Quantum CT that are funding those applications, that are showcasing the use cases. So where federal government might be a little bit slow in going into the software stack, states can really lean in on. I want to finish my questions and then open it up to the floor for questions. I always like to do a lightning round question. So this will be for everyone. I'll start with Andre and we'll come back this way. What excites you most about quantum, and what is also the biggest misconception that you still hear when you go out?
I didn't talk about this much, but what excites me most is the potential of quantum and HPC integration. Let's see, the biggest misconception is, I think, so I've heard a lot over time that, like people stopping by booths and so forth, that, hey, are QPUs going to replace CPUs and GPUs? No, that's not going to happen. Quantum computers are accelerants. They're going to accelerate key workflows, and they're truly a new, innovative processor. And so we're not out to get you. We're here to help.
Yeah, I think there's two things that excite me the most, and I love what I see from my colleagues on the hardware side. I just think the innovation that's happening in quantum is amazing. I mean, when I sit down and look at some of the things that they're doing in terms of on the hardware side, it's mind-blowing of how it actually happens from a physics and from a hardware and from a, it's amazing. What also excites me is on some of these industries, I mean, it's all near and dear. We hear about climate tech. We hear about, therapeutics that they're 10 years away. This is going to open up new spaces that is going to help humanity. And to me, the faster we can bring this forward and find those solutions, we actually are going to do things that have never been done before that are really going to help society. And so I'm very excited about that. I think the misconception is I can wait. I mean, if I asked you all, I won't ask you to raise your hands, it said, if you knew ChatGPT was coming 2 years from now, would you have waited 2 years to get prepared? You probably wouldn't have. You said, oh my God, that's game changing. I need to start now. I need to make sure my business is prepared. I need to make sure I'm organizationally, that I've got everything set up. You would not wait. And that's where we are here. And the biggest misconception is, let me see where things go and I'll wait. And if it's here, you're too late. So my recommendation is figure out how to get started. And everybody has their own journey. It could start small, it could start large, but get informed and get started, because this is not an if, it's a when, and it's coming sooner than you think.
Mark?
Yeah, the thing I'm most excited about is personalized medicine, being able to develop a therapeutic just for a population of one. And the biggest misconception, so I've already mentioned that people mistakenly believe that quantum is just a faster computer. They don't realize it's a different type. The other misconception, it's that they think quantum is science fiction, and maybe this comes from like Marvel movies or something, but they don't realize that it really exists. It's existed for several years. And then also I've heard people, they tell me like it has something to do with their spirituality or something, and they kind of project their personal life into this. And they don't realize, no, we really build computers based on this. We've known for 100 years what the rules are, but now we can take advantage of them. It's a real thing, and many people in the world are using them and building them. I don't think that's appreciated yet.
That's awesome. Thank you so much. If folks in the audience have any questions, please raise your hand. Yes, absolutely.
Someone mentioned manufacturing. I was just trying to think of examples, but let's say you're a mid-sized manufacturer making parts for one of the bigger aero defense contractors or whatever. Where do you see them benefiting or using quantum?
Sure, happy. Why don't we start, since you just finished, why don't we start with Jason on the software side?
We have a tremendous amount of opportunity in looking at spaces of new feature selection, et cetera, in optimization. And so I can imagine, depending on the size and the complexity of your supply chain, many manufacturing companies have tremendously complex supply chains, routing, logistics, global. And so looking at areas where optimization may play a role in the efficiency of the operation, carbon footprint, et cetera, are areas to maybe explore. Of course, if you're manufacturing certain materials, depending on, again, as we talked about, if you're in materials, looking at new materials discovery, but if it's in the supply chain and optimization there, that's where I'd probably look.
Mark?
Yeah. So if the manufacturing includes materials, I would focus on that, using chemistry to develop new materials, which might be lighter or cheaper or what have you. And the other would be exactly what Jason just said, logistics and scheduling to optimize it.
Andre, I know D-Wave has some use cases for manufacturing. Do you want to touch on that?
Yeah, can I borrow? So exactly. I mean, you guys kind of mentioned the use cases, but our annealing systems come to mind immediately. We have our, the annealers and our full stack software services through our cloud available immediately to run those solutions, commercially available today. For your logistics problems, for optimizing any sort of scheduling that you may have, workforce optimization, anything for your, for any sort of manufacturing or, delivery or anything like that. So, yeah, if you have any more kind of specific or concrete questions around that, yeah.
It's always tough to evaluate the cost benefit. Do we go this route? And what do we save versus, what do we spend? So
Yeah, and, I would say you should talk to the different vendors about kind of the applications, the ROIs, the proof of concepts, and proof of technologies. I know that in transportation, logistics, Quantum Economic Development Consortium has created reports identifying use cases, but each company is a bit different. And so speaking directly, understanding the problem set, as Andre said, talking to the different vendors to see if for your specific problem, is there a quantum technology that A, is needed, let alone whether or not it can help solve it. All right, we have a question up top.
Hi, my name is Ajay Shrestha. I'm a recent MBA graduate from here. I'm working in technical function. So my question is how, the impact of the development of advancement in large number of qubits in quantum technology and its impact on cryptography, and more its, the entire internet is basically, safeguarded, secured by, public-private key infrastructure. How would the internet have to evolve to keep up with the advancements in quantum technology so that, we keep the bad actors away from sensitive information? And also, there's been recent papers out of Google saying, their Willow and their recent advancement can potentially even break the elliptic curve cryptography, that's used by, for example, Bitcoin. So just curious about the technical aspect and how both industry, technology, government, and everybody will have to advance, and even society, I guess, because it's safeguarding our banks, right? So just, and the timeline and...
Who wants to take that?
Sell your Bitcoin.
Okay.
I don't know about that, but do you go ahead.
I think there's a lot of work going on the classical side because, doing post-quantum cryptography is actually preparing companies for that potential, which I think, there's concern about that, but, there are companies today that are working with enterprises and institutions to evaluate the vulnerabilities, figure out what needs to be done to address the vulnerabilities in security, et cetera, so we're prepared for those types of advances. As we all know, there's anytime you bring a new technology, there's people that try to exploit it for not such good things. But I think we have a window to fix some of the infrastructure to go do that, and there are companies that are doing that today.
I think we have one more question. Here we go.
Hi, good to see everyone again. My question is to you, Andre. You mentioned that AI for quantum and quantum for AI. Just your thoughts on, is it like equivalent exchange? Does quantum for AI outweigh the utility as AI for quantum, in your opinion? Oh, and everyone else's opinion also.
No, I wouldn't say it outweighs the value. I think that I would say that the quantum for AI is certainly on the gate model side more forward-looking, and there are a lot of really useful applications for AI on the AI for quantum side today, and people are making really good use of AI for that. And it's really important to use AI for that because keeping the human in the loop for error correction and calibration at large scales is not sustainable when the systems get too big. It's smart to start using AI where you can, as long as you're doing it kind of responsibly. But certainly longer term, there's a huge amount of, I would say, commercial value that comes when you start applying quantum for AI, whereas AI for quantum is maybe more kind of back end.
Thank you.
I think one of the other aspects is also in the pre-work that Andre was mentioning for the annealing systems for the work that we're doing with Shinogi. It actually was able to do some of the modeling and the pre-work for the LLMs using energy efficiency. So it was actually to do the model better, but also using less energy. So I think that there is a cross-cut from that. So it depends on what you're looking at for it. With that, I do believe we're at time. I want to thank my panelists. Thank you so much. Thank you all for coming. We'll be around if you have additional questions. Thank you.
It's really good. Allison, I'll pull you for just 1 second. Allison, I'll pull you for just 1 second. Do you mind if I get a photo real quick? Sorry.
Sorry, they like a photo.
One photo and then we'll. Yeah, they do. Yeah, me too. Me too. I need a. Amazing. Thank you all.
One GPU node.
Yeah, downstairs. So we're going down in
A single GPU versus a single.
Thank you.
That's from my perspective. That's what it is. Not a QPU. I like, by the way, this is why that's one of the big values. Those are exciting updates for like AI clients, including some of the issues like we had for a brief period of time. That are like really that's right. Updates and I'm like, oh, this is 5 days ago. That's right. Now, quantum computing isn't replace by the way, guys, when I was down, we quoted, they didn't use it. So check this out. Email from Colby yeah, so I've been like coaching here. I was like, here. And I've just been giving him like total feedback. Well, this was what he said. I said, yeah, we'll talk about more. Yeah, like the other ones, it's like, hey, like I gave a voice note. We're on the second address this. You feel like not that you're noticing complicated and more like this, like that. So then you go this one. It's more thoughtful. So I wanted to anyway. I'll keep you this is great. Okay, so we have like a back. I want to be like, I trust you. But Joe combination, he is when he's like swinging around. There's also a flexion because I'm like invested. I'm invested. Like I live in Yale. I'm like at a time.
That was great. Thank you so much.
I think hey, you invest in this.
Yeah, so we have.
Yeah, well, I know, like, I'm not making money back in the conversation. He's like, I see you leaving. I'm like, I already had made this decision because that was like, I made the decision. It's like, it's just kind of, everything's just like, serendipitous timing, and it's like, oh, like,
So we find that's Minecraft. We can pick our language, but I choose. And that's how she sees it. And I'm just hearing you. I'm just so you when you said I have to, but that kid is so talented. And you know
The only thing is, like, if you can show me that you can just scale that minutely,
so it's more like,
then
you like, you have a whole professional service. When you make it,